So functions is a really important topic. If you're a student in years 11 and 12, it's not something that's entirely new. It's basically like an extension of algebra that you guys would have done in years 9 and 10, years 7 and 8, and even using your basic skills that you've done in your primary school or your elementary schools. Um, but we do introduce some sort of new notation and we introduce some new concepts within here, which can sometimes be a bit confusing for students. So this video is basically just going to be trying to give you guys a simplified introduction of what the concept of functions is, and just basically just explain and deconstruct some of the notation behind it. Just so you guys are familiar with that, because it is a very important topic. Once you guys get into year 11 and 12, if you're already in year 11 and 12 or 12, it's something that you're going to be using, in all your maths topic. It's not something that's just like it's standalone. It's basically it's integrated within the whole curriculum. It's integrated within the whole syllabus, and even when you're learning other topics like trigonometry or exponentials and logarithms, you're still going to be using functions in some sort of way. So to describe what a function is, in simple terms, we have an input. Okay, so we have something that we put in. Something happens. So it's like, imagine like a machine. Something happens, and we get a final output. Right. That's basically what functions are. Okay. So if you think of like I don't know. Let's think of what's a machine. Let's say like a laminating machine. Right. If you have a laminating machine, what do we input? We input a piece of paper into the machine. Okay. Now, what does that machine do? It has its own process. It does some some mechanical stuff. And what do we get as our output? At our output, we get a nice laminated sheet. Okay. So that itself is a function. Now we also we're basically doing the same thing in mathematical terms. And that's what we call a mathematical function, right? So we have some sort of input. It's usually a number or a variable or something like that. We have some sort of input. We do something to that input, right? So we do some sort of operation to it, some sort of mathematical operation to it. And once we do that, we get a final number. Okay. So to give you a simple mathematical example of that, let's say we have the number 29, right? Just a random number. Okay. Now what our function is going to be, our function is that we're going to perform the operation of addition. Okay. In this case specifically, we're going to be adding 100 to our input. Okay. So that is basically what the function is. Okay. So we have an input here, right? That's the input. The function is the stuff in the middle that gives us the output, right? And the output of this particular function is going to be 129. Okay. So 29 is just one example. Let's say we have another number, right? Let's say we have the number 5. Okay. Let's get a pen. Let's say we have the number 5. So we have the number 5. Again, performing the same sort of function, we're adding 100. What's that going to give us? That's going to give us an output of 105, right? Because we're doing the same function. Okay, that's just a simple example. All right, another example here. We've got the number 5, so that's our input again. Now this time, our process or our function is squaring, right? What does squaring mean? Squaring, we know, means that we're multiplying the number by itself. Okay, so if you multiply our input here by itself, if you multiply 5 by itself, we get 5 times 5, which is 25, which gives us our output. Okay, so that's basically in simple terms what we're doing in a function, right? A function, we have an input, we have some sort of input, and then we're doing something to it, some sort of mathematical operation to get a final output. Okay, now we're going to be introducing some sort of notation. You may have seen this before, you may not have seen this before. But our function notation, if we look at this right-hand side here first, we have something called f of x is equal to x squared, right? That's an example of function notation. Now, if we sort of pull that apart and deconstruct it, let's have a look at what this sort of means, okay? So we've got the letter f here, and f stands for the name of the function, right? So We usually use f because it's f for function, but you can have other letters as well, right? You could have g of x, or you could have h of x, or you could have, uh, you know, x of x, you know, or the z of x. Okay, it could be any sort of letter here. It could be at the front, but that's just implying the name of the function. Okay, and now you would notice when I said this, I said f of x, right? And what that means is that the function is of the input x. Okay, so this is our input here. So that's why we say f of x, because we're saying whatever our equation is, it is a function of x, right? It is a function of the input x. That's what we mean. Okay, and on the right hand side here, we have x squared. So that is what we're actually doing to the function. Okay, what the actual function does, right? How well, what the final output is going to be. It gives us sort of an equation that tells us how to calculate the output given we have the input x. Okay. One thing to note is that we have f and x here in brackets. You might have seen that sometimes when we're doing multiplication, we usually do something like this. So let's say we want to do 3 times 2. We sometimes do something like this, right? We just say 3 and we put 2 in brackets. Okay, now that implies we're doing 3 times 2, right? We just need to make sure that when we have something like this, when you have f of x, we're not implying that. We're not saying that we're multiplying f by x. Okay, we need to understand that this is just a notation we use to describe the function. Okay, so f is the name of the function and x is the input. Okay, so looking at the same examples that we used, we looked at earlier. So we have the same function here. So we have the input 29, and we are adding 100 to give us a final notation. This should say 129. That's a mistake here. Sorry about that. That's 129. Okay, so how to write that in function notation? So again, we have f of x. Okay, so we have a function of x, and that is equal to x plus 100. Okay, so we have an input x. In this case, our input was 29. We add 100 to it, and we get our final function. Okay, or our output. Okay, this one is all same thing. We have f of x is equal to x squared. Okay, so again, our input is x here. So x can be many things, right? We're just taking one example of it, but x could be 1, 2, 3, 4, 5. It could be negative 10,000. It could be 0. It could be 1 million. All right, it can be anything. Okay, in most cases, we'll have a look at what a quantum can be in a different video. But for now, we're just sort of saying that it can be any number. Okay, and it gives us the final output, which is 25. And that's how we write it in our function notation. Now, if you have a look at a question, so again, it's given us a function is defined by the rule f of x is equal to 1 plus 5x. And from here, we have to find these 3 values, right? So basically what these are just 3 different inputs for the same function, okay? So we have 3 different inputs, which are going to give us potentially 3 different outputs, okay? So we look at the answer for this. So that's our function here. F of x is equal to 1 plus 5x. And all we have to do is, when we're doing f of 3, wherever we see x, we're just going to substitute the value 3, okay? So f of 3 is going to be 1 plus 5 multiplied by 3, okay? Which gives us 16. F of 0 is just going to be 1 plus 5 multiplied by 0, which just gives us 1. F of minus 1 is equal to 1 plus 5 times minus 1, which is negative 4. So you can see here we've got 3 different inputs. So we've got 3, 0, and negative 1. So these are different inputs. And for the same function, they're giving us 3 different outputs as well. Okay? So we've got 3 different inputs, and we're getting 3 different outputs. So you can see it's kind of like a machine, right? You input a number, you do some sort of calculation, and you get a final output. Okay? Now, an input doesn't just have to be a number, right? So we've looked at these examples, and we've just all of these three inputs are numbers. We can get some cases where our input itself is another variable or another sort of an algebraic term. So this question here, for example, we've got g of x is equal to negative 4x minus 5. So again, that's another function. Now instead of f of x, we'll just use g of x. Okay, doesn't change anything. It's just we're using different letters. Now from that, we have to find the value of g a squared minus 7. Okay, so it's sort of the same principle. It's just a bit more difficult. Not difficult, it's a bit different in the sense that now instead of wherever we see x, we're going to be subbing in a squared minus 7. Okay, so you have negative 4 multiplied by, instead of x, we have a squared minus 7. And then we have minus 5 at the end. Now this minus 5, again, that stays by the same. And what do we call something that's by itself, that doesn't get changed, that doesn't have any sort of prenumerable attached to it? We call that a constant. So in this case, negative 5 is a constant. Okay? Now if we expand this part here, we will get negative 4a squared plus 28 minus 5. We can simplify that to negative 4a squared plus 23. And again, that's our final output. Right, so same sort of thing here. Okay, we have, this is our function here. Okay, and inside that function goes this output. Okay, and when you put that output in this function, we get, so when we put this input in this function, we get this output. Okay, so the key takeaway from this lesson or from this video would just be that you guys understand that functions are basically, we are inputting a number or a variable or some sort of inputting some sort of equation or variable or constant or whatever it is into a function, which is some sort of mathematical operation, and that's going to give us a final output, which is again going to be either a number or some sort of algebraic expression of some sort. Okay,